Welcome to the second part of our lecture on the clinical examination in making a diagnosis. To recap, there are three aspects of the clinical examination of the individual animal, and this includes the animal, the history, and the environment. So this presentation will focus mainly on the examination of the environment. This presentation will discuss the clinical examination of the individual animal, and we are going to focus on the examination of the environment, so the different parameters that we are going to examine under the environment, particularly the outdoor environment. The succeeding slides will answer the question why there is a need to examine the environment when we are going to make a clinical examination and diagnosis. There are two aspects of the clinical examination of the environment. This includes the outdoor environment and the indoor environment. So this presentation will mainly focus on the outdoor environment. These are the parameters that we are going to consider when we are going to examine the outdoor environment. So the first one is the topography and the soil type. We also have the stocking rate, the feed and the water supplies, and the waste disposal. There are two critical elements of all grazing operations: the number of livestock and the amount of pasture land. These two elements are often the most expensive assets of grazing systems. One of the important key to a successful livestock production system is to keep records of the stocking rate. What is stocking rate? This is defined as the number of animals on a given amount of land over a certain period. It is expressed as animal units per unit of land area. It is associated with the carrying capacity of that particular land. When we say carrying capacity, this is the stocking rate that is sustainable over time per unit of land area. We need to determine the stocking rate because we need to match the amount of forage produced with the amount of forage needed per animal without compromising either resource. Too many animals in a field result in overgrazing. There is not enough forage to feed the livestock. Over time, the pasture may become patchy and infested with weeds, resulting in a need to buy costly supplemental feed. On the other hand, too few animals result in underutilized forages and therefore potentially lost income. Over time, you will observe mature forages and uneven grazing in some spots of the pasture. A term that is used to understand and estimate forage requirement is the animal unit or the AU concept. So in this diagram, you have here the definition of what is now an animal unit. So when we say animal unit, that is a 1,000 pound cow with its calf. We also have here some definitions: the animal unit day, animal unit month, and the animal unit year. So when we say animal unit month or AUM, that is the amount of forage required by one animal unit for 1 month. So we have here our animal unit day. The animal unit day or the AUD is the amount of forage required by one animal unit for 1 day. So how do we get 26 pounds of dry forage? So we get that based on the animal intake of 2.5% to 3% of the body weight per day on a dry matter basis. That is adjusting for moisture content for feed. Now, for example, a 1,000 pound cow eating 2.5% to 3% of its body weight eats about 25 pounds per day. Now, how do we get 25 pounds? So in our example, we have here 26 pounds of dry forage. So how do we get this value? So we just multiply the weight of the animal, that is now the 1,000, which is equivalent to our animal unit, the 1,000 pounds, and multiply that with 2.5% or 0.025, and we have a result will be 25 pounds of dry forage. Now, that is the requirement of a 1,000 pound cow per day. So in this example, the author used 26 pounds of dry forage. The animal unit month is again the forage requirement of an animal unit per month. How do we get this 780 pounds of dry forage? We just multiply the 26 pounds, which is the animal unit day, and multiply that with 30 to get 780 pounds of dry forage. We also have here the animal unit year, and we take this value by multiplying 26 pounds by 360 days, so that is 9,360 pounds of dry forage. Because cattle and other grazing animals are not the same size, it is often necessary to convert to animal unit equivalents. The term animal unit equivalent is useful for estimating the potential forage demand for different kinds of animals or for cattle that weigh more or less than 1,000 pounds. It is based upon the percentage of the standard AU or animal unit and takes into account physiological differences. This table represents the animal unit intake or AUE and the estimated daily forage dry matter (DM) demand for various kinds and classes of animals. The first column represents the animal type. We also have here the second column is the AUE, and the third column is the dry matter demand in pounds per day. Our first animal is cattle. So we have here our cows weighing 300 pounds to 600 pounds, and we also have here our cow. Our cow is our animal unit because it is estimated to have 1,000 pound. Again, when we say animal unit, that is 1,000 pound cow with its calf. For its dry matter demand is estimated at 26 pounds per day. How do we get 26 pounds? So we just multiply the weight of our animal, 1,000 pound, and multiply that with the 2.5 to 3%, which is the animal intake. Animal intake in percentage on a dry matter basis. So for example, the 1,000 so 1,000, we multiply that with 0.025 is equivalent to 25 pounds. And when we multiply 1,000 times 0.03, that is equivalent to 30. In our example, the author estimated it to be 26 pounds per day. For a 600 pound calf, it has an animal unit equivalent of 0.7 and it has a dry matter demand of 18. How do we get 18? So the same with our previous example, we multiply 600 pounds and we multiply that with 0.025, which is the estimated animal intake of the animal on a dry matter basis. So 600, which is the weight of our animal, 600, multiply that with 0.025, or rather we use 3, 600, we multiply that with 0.03 or 3% of the on a dry matter basis. 0.03, that is equivalent to 18, and the same is true for other examples. So 500, for example, 500, and we multiply that with 0.03, that is equivalent to 15 pounds per day. So we just multiply the weight of the animal and we multiply that with the animal intake, that is 3% on a dry matter basis. In the case of horses, it has an animal unit equivalent of 125, and its dry matter demand would be 32 pounds per day. How do we get 32? So in this case, the weight of the animal is not given, so we can estimate the dry matter demand by just multiplying the animal unit equivalent with our standard, which is for the cow. One, our cow is our animal unit, and its daily demand is 26. So we just multiply our animal unit equivalent, which is 125, and we multiply that with 26, and the result is 32.5 or 32. For sheep, the same. So we just multiply our animal unit equivalent, which is 0.2, and we multiply that with 26. So that is equivalent to 5.2 or 5. For goats, our animal equivalent unit is 0.17, and its daily demand is 4. How do we get 4? We just multiply our animal unit equivalent, 0.17, 0.17 by 26. So we get 4. So under the sucking rate, we have overcrowding. So this is considered to be a common predisposing cause of disease. And there is, in overcrowding, there is an excessive buildup of feces and urine. So these are sources of ammonia. And this can increase the level of infection in the farm. Another factor that we are going to consider in the examination of the outer environment is the topography as well as the soil type. So when we say topography, that is a graphic representation of the surface features of a place or region on a map, indicating the relative positions and elevations. So the presence of a flat, treeless plains with no protection from the wind can predispose cattle to lactation tetany in inclement weather. So the other term for lactation tetany in cattle is hypomagnesemic tetany. Now this is an acute neurological condition due to a low dietary intake of magnesium, typically affecting lactating dairy or lactating cattle. We also have low marshy areas in damp conditions can also facilitate the spread of insect-borne diseases, leptospirosis, as well as liver fluke infestation. When the soil is predominantly made up of littoral sands, it can predispose animals to developing copper and cobalt deficiencies. The drainage and the surface of the ground, as seen in the figure, is also an important aspect in highly intensive beef feedlots and large dairy herds in total confinement. So we also have the feed and the water supply. So for the outdoor environment, in terms of the feed, we have the pasture. So this has to do with the presence of the dominant vegetation. So for example, there are certain vegetation that are rich or that has a predominantly high estrogen content of some clovers. So in some countries, there are species of plants which are known as clovers, particularly the red clovers, which has a high estrogen content. We also have some plants that are selective absorbing converter plants on copper and selenium-rich soils. So the figure shows a summary of the known and postulated sites of action of compounds from plants that are said to be estrogenic. So these plants have a high content of estrogen, or this is what we call phytoestrogens. So what is the significance of this? So this study was done in sheep, and it has been observed that consumption of plants or pasture having a high content of estrogen or phytoestrogens can lead to compromised sheep reproduction. As seen in this figure, this here is the normal reproductive tract of sheep, and this is the abnormal one with a clover disease. So as you can see here, there is a difference between the uterus of this sheep having a clover disease and this which has a normal reproductive tract. So what happens here is there is endometrial thickening and edema. In okay, there is also, aside from that, there is also a loss of the cervical fold, in terms of this portion here, of the reproductive tract of sheep with clover disease. In letter C, we also have the excessive estrogen-like actions in the neuroendocrine control of reproduction. So it has to do, with the neuroendocrine control already. In letter D, we have here the reduction in the follicle development, quality, and potentially ovulatory ability are reduced. In letter E, there is the interaction between the spermatozoa and the female tract is altered. So of course, it can result to a disruption in the reproductive performance of the animal. There is also a loss of the cervical crypts, changes in mucous composition and consistency of the changes in the female immune response. In pasture, we also have the presence of specific poisonous plants. Evidence of overgrazing can also be determined through examination of the environment. So this plant here is a Hagonoy, Chromolena odorata, also known as the devil weed. In terms of its effects, it has been studied. It has been reported to cause adverse effects in the kidney. So this plant has been shown not to be toxic to cattle. And the study evaluated the effect of ethanolic plant extract on the kidney, as well as the intestines of albino rats. So results showed that the use of plant extract has adverse effect on the kidney function and histology of the rats in the study. We also have another poisonous plants are the species of Lantana camara. It has been reported to affect species such as cattle, sheep, goats, guinea pigs, and rabbits. The physical nature of the pasture plant is also important. Mature bleach grass pasture, which is deficient in beta-carotene, as well as the lush young pasture, which is high in carotene, can also have rachitogenic potency. So when we say rachitogenic potency, that is ability to cause rickets in animals. For animals in confinement outdoors, the feed supplies must also be examined for evidence of moldy feed, as shown in the figure. Contamination of the feeds with feces and urine, as well as the excessive moisture. In terms of the drinking water supply, so the water in the ponds may be covered with algae, as shown in the figure. It may contain neurotoxins or hepatotoxic agents. So in particular, the blue-green algae can produce neurotoxins, liver toxins, and skin allergens. Livestock, dogs, and people can become poisoned by ingestion of algae, either in the water or as dried mats on shore, or from drinking water, where algal death has released considerable toxins into the water. In terms of the flowing streams, they may also carry effluent from nearby industrial plants. So when we say effluent, these are liquid waste or sewage discharged into the river or the sea. Wastewater and greywater use in irrigation are essential sources for sustainable water management in arid lands, promoting the preservation of limited freshwater resources, as shown in the figure. So this figure here shows um, the gray water coming from household. We also have the black water, and this is the gray water collection tank. So when we say gray water, these are the these are actually 50 to 80% of this are residential wastewater. This is mainly comprised of water collected separately from sewage flow that originates from, for example, clothes washer, bathtub, showers, and sinks, without the wastewater from the toilet. So the use of gray water for irrigation would reduce the demand on water resources and alleviate the pressure on wastewater treatment plants. So in this particular figure, we have here the gray water from the household, and we also have here the wastewater treatment plant. So it will undergo treatment in the wastewater treatment plant, and the products from this plant will be again treated for the purpose of irrigation of the crops, and of course this can also help the animals, since the plants now from the irrigated crops uh, can produce crops that are, of course, that can be fed to animals as well as humans. So the last parameter, under the outdoor environment is the waste disposal. So of course, the problems that are seen under this are the disposal of the feces and the urine. This is considered to be a major problem in large intensified livestock operations. So the lagoons can also provide ideal conditions for the breeding of the flies. So the flies are carriers of diseases, and this can also greatly affect the health of the animals. So basically, when we say lagoons, these are pond-like earthen basins sized to provide biological treatment and long-term storage of the animal waste. So what happens here is that there is enhancement of the microbial digestion of the organic matter, thereby reducing the land area requirement for disposal by 50 to 75%. The livestock lagoons are also small-scale waste treatment plants containing manure that is usually diluted with water and rainfall. So because this is an open pit, so the rainfall can dilute the manure that is present in the lagoon. Dilution controls the ammonia and salt concentrations present in the lagoon so that bacteria can function properly. So this is an example of a wastewater treatment lagoon for poultry. This is an example of lagoons that are present in swine. So these are the barns now housing the swine, and these are the lagoons. The lagoons are commonly used in swine farms because swine waste is easily moved in liquid forms. This is an example of a swine waste lagoon in Georgia, USA. Lagoons also poses a public health concern. So, for example, the manure lagoons on this hog farm in USA, North Carolina, were flooded after a typhoon, a Hurricane Floyd, in the year 1999, creating environmental and health concerns for the nearby rivers. So this is a framework of the agricultural waste recycling in pig farms. So the crop straw as well as the manure coming from the pigs can be recycled through fermentation technology to produce biogas energy for clean production, and can be transformed into high quality agricultural organic fertilizer, such as seen in this figure. Now we have the biogas slurry. The biogas digester, so this part here of the framework is a biogas digester, and this is important to convert the manure into um, products that are important, for energy as well as for fertilizer. So in this case, we have here the products of the biogas digester is the methane that can be used for electricity. We also have another is the biogas slurry that can also be used for as a fertilizer, as a feed, and also to fertilize crops. Additionally, we also have the inadequate disposal of the dead animals. This is also an important factor in the spread of certain diseases. There are different ways by which dead animals can be disposed, and one of that is through burning. Now, this is according to the FAO. When we say burning, that is a process which involves constructing a bed of combustible materials such as wood and timber, placing the carcasses on the bed, and adding more combustible material over the carcasses, and igniting the pile. Now, so as shown now in this figure. So these are the advantages and the disadvantages of open burning as shown in this figure or as shown in this table. So among the advantages of open burning is that it can be conducted on farm. Of course, when you do burning, it can inactivate the pathogens and it can also reduce the volume of the animal or of the dead animal. For the disadvantages of open burning, so it can be a risk, a biosecurity risk, now since there is a piling of the dead carcasses on an open site. It is also not sustainable, no, because in the first place it is said to be expensive and slow process. It has also a public opposition, a problem on the public opposition, mainly because of the smell, a very bad smell, coming from the burning. And of course, it can also cause the degradation of the air quality as well as poses a risk of creating wildfires. So it is also considered to be inefficient method and it is of course difficult to operate and it has regulatory limitations. So we have here another method by which the dead carcasses can be disposed is via the deep burial. This is again according to the FAO. So in the deep burial, this involves removing the soil from the ground to a depth of 3 to 5 meters, piling the soil nearby for later use, depositing the carcasses into the excavated area, and then covering the carcasses with the soil that had been previously removed, as shown in the figure. So this figure shows the schematic diagram of how the deep burial is being done. So this area here represents the how deep is the structures that will be made. So this is a burial pit. This is a burial pit where the animals will be disposed. And according to the reference, it is about 3 to 5 meters in depth. And of course, now under this we have we have here the soil, and under that is the groundwater and the soil itself. So this is the length of our, or the depth rather, of our structures. So we have here a 0 BGS, so below ground surface in meters, for 10 meters below ground surface and 12 meters below ground surface. So this is the burial pit that we are referring to. And once the carcasses are buried, what happens is they undergo anaerobic decomposition and break down into minerals and organic matter. This, according to the references, is a very slow process and it takes about decades. The anaerobic decomposition process will generate body fluids, and this body fluids is known as the leachate. The leachate will have the tendency to slowly penetrate the native soil beneath the burial site and may reach the groundwater. So the most significant Deep burial exposure pathways are chemicals leaching to the groundwater and surface water to fish, ingested by humans, livestock, and pathogens, leaching to groundwater that is ingested by livestock. It is also possible for viruses to be transported to the groundwater, and therefore during an outbreak, the potential for farm wells to become contaminated with virus should be considered. So this is a residential area, and some of the people take their water from the wells. So the wells could be contaminated with the leachate that could possibly contain viruses and other pathogens coming from the burial pit. So this could contaminate the groundwater. So the carcass leachate is shown to contain over 12,000 milligrams per liter of nitrogen as ammonium. So as shown in the figure, the carcass leachate can contain about 12,600 milligram per liter of ammonium, which is of course detrimental to the uh, organisms that can be exposed to this high amount of ammonium. According to the WHO, the drinking water standard should only have a content of about 50 milligrams per liter for it to be not to be considered as a drinking water. So this could really pose a threat to the public, because this level here is very high compared to what is the standard according to the WHO. These are the advantages and the disadvantages of a deep burial method. In terms of its advantages, it can be conducted on farm and it is said to be easy to implement. In terms of its disadvantages, it is considered to be a public health risk, because again, the leachate coming from the dead carcasses can slowly penetrate the groundwater. It is also a biosecurity risk since the leachate coming from the dead carcasses contains some pathogens such as viruses, which can again leach into the groundwater. Pathogens may also survive because the carcasses are not treated. No, they are not burned, they are not treated. They are only buried into that particular pit. This is also not sustainable because, again, because of the public health concern. Limits a future land use because, again, when you are using land in order to bury dead carcasses, so of course it could consume the land area that is available in your farm. It requires heavy equipment for excessive labor. Because you need to make an excavation that is about 3 to 5 meters in depth in order to make this particular method. So for the considerations, burial may be viable for small numbers of animals in suitable soil, but it should be site specific. So this is not recommended for big farms having high number of mortalities, since again it requires it consumes the land that is available for producing the animals. Another method is the above ground, the above ground burial. So what is this above ground burial? It is a hybrid of the deep burial and composting, which includes a shallow trench excavated into a native soil, to a depth of 60 meters, as shown in the figures. We have here a shallow trench that was utilized in order to make this particular method. So the depth of the trench is about 50 to 60 meters, or rather 50 to 60 centimeters. And we also have here a 30 centimeter or of carbonaceous material placed at the bottom of the trench, followed by a single layer of animal carcasses. So, single layer na isang pile lang siya. Then, the excavated soils are subsequently placed back in the trench. Ito yung ano mo, yung soil that was excavated earlier, no, before the excavation. So it forms a mound. So pag ibabalik mo na yung soil, so since the trench is shallow, so it will form a mound on which the vegetative cap is established. So these are the advantages of the above ground burial method. So it is said to be safe and it can be conducted on farm. It is readily available. It is fast to implement. It has public acceptance as opposed to the deep burial method. No? And the pathogens in the bone marrow may also be inactivated, no, according to some preliminary studies. And the scavengers are not observed to disrupt properly constructed piles. So again, this has a public acceptance, no, because one thing is that it do not create a leachate and it is safe for the groundwater. So since it is not as compared to that of the deep burial, the deep burial has a tendency to form a leachate that will contaminate the groundwater, and this is absent for the above ground burial. Now, that is why the acceptability is far better, compared to the other one. Another method for the carcass disposal is through composting. So in composting, this is a process that involves constructing a porous base layer of carbon material, such as wood chips, mixing or layering carcasses with carbon material for the core of the windrow, and capping with a blanket of carbon material to promote decomposition of carcasses at elevated temperatures. So according to our reference, now, the most significant composting exposure pathway are chemicals leaching to the groundwater and surface water. For the advantages of the composting, so it can be conducted on farm. It is safe, sustainable, and easy to implement. For its disadvantages is the time to complete, because you need to layer, for example, the carcass with the carbon material and other materials to do the composting. It is considered to be expensive and it requires an eligible experienced operator to ensure proper construction.